Welcome to our lesson on scalar and vector quantities in physics. These two types of quantities are fundamental to understanding how we describe physical phenomena in our world. Let's start with scalar quantities. A scalar quantity is a physical quantity that has only magnitude but no direction. Examples of scalar quantities include temperature, mass, time, distance, speed, work, and energy. Let's visualize some scalar quantities with examples. For example, temperature only tells us how hot or cold an object is, not in which direction the heat is moving. If I say it's 30 degrees Celsius outside, that value only indicates the magnitude of heat, not its direction. Similarly, mass is also a scalar. When I say an object has a mass of 5 kilograms, I'm only specifying how much matter it contains, with no mention of direction. Now, let's move on to vector quantities. A vector quantity is a physical quantity that has both magnitude and direction. Examples of vector quantities include displacement, velocity, acceleration, force, momentum, and electric field. Let's visualize some vector quantities with examples. Displacement is a vector that represents the change in position of an object. For example, if a person walks 4 meters east, their displacement is 4 meters east. It has both magnitude, 4 meters, and direction, east. Similarly, velocity is also a vector quantity because it describes both how fast something is moving and in what direction. For instance, a car traveling at 60 kilometers per hour north has both speed, 60 kilometers per hour, and direction, north. Let's compare scalar and vector quantities with some practical examples. Consider speed versus velocity. Speed is a scalar quantity that only tells us how fast an object is moving. For example, 60 kilometers per hour. Velocity, on the other hand, is a vector quantity that tells us both speed and direction, such as 60 kilometers per hour north. Similarly, distance and displacement are different. Distance is a scalar quantity that represents the total path length traveled, while displacement is a vector quantity that represents the straight line distance from start to finish, along with the direction. Let's look at how we mathematically represent scalar and vector quantities. A scalar quantity is represented by a single real number. For example, mass, m equals 5 kilograms. A vector quantity is typically represented with an arrow above the letter or in bold. For example, velocity vector v equals 3I plus 4j meters per second, where I is the unit vector in the x direction and j is the unit vector in the y direction. Let's summarize what we've learned about scalar and vector quantities. Scalar quantities have only magnitude with no direction. Examples include temperature, mass, time, distance, speed, and energy. Vector quantities have both magnitude and direction. Examples include displacement, velocity, acceleration, force, momentum, and electric field. Understanding the difference between scalar and vector quantities is essential for solving problems in physics and engineering. Thank you for watching.